Francis Galton was born in 1822 and died in 1911. He was a scientist or a social scientist who contributed to biology, mainly genetics, psychology, anthropology, and he introduced statistical methods to answer scientific questions, which is a change from what typically happens today, in which we adapt our scientific questions to the available statistical methods. Let's start with what he had to say at the beginning of his book Inquiries into Human Faculty in 1883. The living world does not consist of a repetition of similar elements, but of an endless variety of them, that have grown, body and soul, through selective influences into close adaptation to their contemporaries, and to the physical circumstances of the localities they inhabit. This quote has profound statements. First of all, he's talking about the living world. So we've been talking about physics, particles, but do the laws of physics apply to the living world, to the organisms? So he's putting focus on living organisms, and that will be his contribution to science. And he says, living organisms are no repetition of similar elements, they vary. And thus, again, his focus on variety, how people or organisms differ. So he measure everything you can imagine to find how organisms vary. And then he tries to give an explanation to the variety. He says that this variety have grown. So it's not a variety that was there forever, something that changed. And then he says how? He says through selective influences into close adaptation to their contemporaries and to the physical circumstances of the localities they inhabit. He's talking about evolution. And finally, in the middle, he says that this applies to body and soul. So evolution is not just about the body, but about the mind. So that's the focus, that's the approach of Galton. Now let's see how his approach contributed to many areas of science. He started his career as an explorer and geographer. He inherited a good amount of money and he financed his explorations through Africa and made contributions to geography and meteorology. He also contributed to the use of fingerprints. He didn't come up with the idea of fingerprints, but he used statistical methods that were fundamental for courts to start using fingerprints in order to identify people. But his main contribution is the anthropometric laboratory that he set up in London. In this laboratory, he measured people in everything you can imagine. Anthropometry comes from humans, so he measured everything in humans. He measured their height, the color of their eyes, their weight, but he also developed instruments to measure their reaction time, their discrimination, recognition of things. So in this lab, it was about measuring things psychological and non-psychological, but everything about humans. He was interested in genetics, as the Austrian Gregor Mendel and the Reverend Thomas Bayes, he planted peas and then he measured their height. And when he measured their height, he discovered that if you put all the pea plants together, you can find this shape, what he called the ogive, in which very small plants are rare, very tall plants are rare, and most plants are somewhere in around the average height. So in genetics, he developed again statistical methods, biometric approach to genetics. In statistics, he invented the concept of, first he called it reversion, and then regression, or regression to the mean. Reversion was because he was trying to find a causal explanation of what he found, but then he realized that the phenomenon he was after was merely statistical, so he changed the word reversion to regression. Then he developed the correlation coefficient, then formalized by his mentee, Carl Pearson, and he made contributions to the understanding of the normal distribution. The normal distribution was developed by Laplace and Gauss. The distribution is also called the Gaussian distribution. But he developed an instrument to try to understand and to develop insights on the understanding of the normal distribution. That's called the quincunx or the Galton board. Finally, in psychology, he, as I mentioned, in his anthropometric laboratory, he has instruments to measure things. So he was one of the founding fathers of psychometrics. And because he used methods to measure and to develop instruments to measure and statistical methods in order to understand how people differ, he is the founding father of differential psychology. He invented the questionnaire. We use questionnaires. Psychologists all around the world today, they investigate using questionnaires. Galton was the first one who used questionnaires to ask things about psychology. He's studies in genetics, and he's interested in psychological traits. Made him one of the founding fathers of behavioral genetics. He proposed to study twins, and the twin method is one of the methods that was the most important method in behavioral genetics. One of the questionnaires he developed was a questionnaire about mental imagery. He asked people about the vividness of their imagination, the content of their imagination. It was a more descriptive study or qualitative study. He didn't use the statistical methods to contribute to mental imagery, but is one of the first studies about mental imagery. And finally, and this is dear to me because this is my area of research, his contribution to the study of how people acquire expertise, we can situate him in one of the extremes, in theoretical extremes in this area of research, which is that practice is not as important as people think. Mainly, our skills are innate,